The third problem gave you the information that you have the numbers in a table with the first row representing probabilities related to airport 1 and probabilities related to airport 2. The first column representing airline A, second column representing airline B, and the numbers represent the probability of any given flight being on time. You're also given that the numbers of flights from both airlines at both airports are equal. So we rearrange the given information, arrange the given information into this table, and ask for the probability that a flight leaves left from airport 2 given that the flight is delayed. Well, since we're talking about delayed rather than on time, we want to do a table similar to this one, except we're going to have the probability of a flight being delayed rather than on time. If the probability of a flight being on time is 0.73, then the probability it's delayed is 0.27, 1 minus 0.73, because the probabilities of being delayed or being on time have to add up. The probability of being delayed and the probability of being on time have to add up to 1. Okay, and we do similarly here, so now we have the probability of flights being delayed. Now we're asked to find the probability that a flight goes from airport 2 given that it's delayed. The conditional probability formula that you should know is probability of B given A, probability of A intersection B divided by the probability of A. And we need a little discussion of that idea. We do a Venn diagram. Here's event A, here's event B, and here's where the events overlap. Now, if we're trying to find the probability of event B, given that the event A happens, what we're looking at is the number of events in A, okay, being the total number of possible events now that we're given that the event is in A, and the probability that an event is also in B. Well, the part of B that's in A is right here. I've got it kind of shaded in green. This intersection here, of course, is A intersection B. B happens given that A happened. Okay, this is the set of events where B happens and A has also happened. There are events out here where B happens, but A hasn't happened out here. So we're restricting, essentially restricting our sample space to the set A, and we're talking then about the events that occur here in the intersection of A and B. Well, the probability that an event is in this intersection, given that it's in A, is a probability that it's in A intersection B divided by the probability that it's in A. Okay, so this probability would be the probability that a flight leaves from airport 2 and is delayed divided by the probability that the flight is delayed. Now at this point, unfortunately, we chose not to continue because this problem turned out to have a couple of twists in it that theoretically you should be able to deal with, but practically at the level of this course I wouldn't expect people to be able to deal with it. So at this point we abandon our effort and I'll say that if you do get this problem, it's best to do all you can with it. If you do this and quote the probability formula and so forth, I'd probably give you full credit, but I won't count the problem against you even if you leave it blank. So the deal that I said is that this problem counts this problem replaces the lowest credit problem on your test. That is the problem you do worst on. If you do okay on this one, if you do better on this one than you do the worst credit problem, then it replaces that problem. Otherwise, it's not counted. And I could get into the, since the problem stated that you have equal numbers of flights, both airlines, etc., it is possible to solve this with the given information. You would average these two probabilities, or if you had different numbers of flights, you would do a weighted average of the two probabilities to get this. And then you would be able to get the probability that a flight is delayed by averaging all four of these numbers. However, you wouldn't generally do that because you wouldn't have equal numbers of flights by each airline from each airport.